Hey guys, Mr. Middleton here. Today we're looking at areas of circles and sectors notes. At the end of this video, you should be able to find the area of a circle as well as portions of a circle. Okay, last lesson we looked at the outside of the circle, and today we're going to look at the inside of the circle. Okay, so last lesson we looked at the pizza crust. Today we're looking at the toppings. Okay. Inside area. Okay, all right. The shaded region of a circle is called a sector. To find the area of a shaded region, we think of it as a fraction of the area. Okay, similar to how we thought of the length of an arc being a fraction of the circumference. Okay, to find the area of a circle, we use the formula area equals pi times r squared, where r is our radius. Okay, the fraction comes from the measure of the central angle or the arc, since they correspond, right? So the area of this shaded region is found by using 120 over 360 times pi r, in this case our radius is 9 squared. Okay, so the measure of our arc over 360 tells us the fraction or the percentage of the circle that we're dealing with, and in this case it simplifies down to 1/3. 9 squared is 81 pi. So 1/3 of 81 pi, that is 27 pi. And I'll just say units squared because we're dealing with area. Okay, so it should be pretty straightforward here. All right, so let's look at a couple more examples. Bottom here we have in a sector with the arc being 60 degrees. And so we can set this up similarly and say 60 over 360 times pi r. In this case, our radius is 8 squared. So 60 over 360 simplifies to 1/6. 8 squared is 64. So we have this as 64 over 6 pi, which simplifies further down to 32 over 3 pi. We'll say units squared. Number 2, you'll notice that they did have numbers written down, but we know this angle, or this symbol means that it's 90 degrees. Okay. This is 90 degrees of the unshaded part, so if we're trying to find the shaded region, then we need to have all of this stuff, okay? And we know a circle should be 360, so 360 minus 90 gives us 270, the measure of the central angle, or the arc, I guess it's better to say, the measure of the arc of our sector. So 270 over 360 times our radius isn't given to us the same way either. Notice that we have this 14-foot measurement. It's written on the outside, but it's definitely telling us from basically the tip of the circle to the tip of the circle. It's giving us a diameter. So if our radius is 14, or sorry, if our diameter is 14, we should be able to find our radius by dividing that by 2. So our radius in this case is 7 feet. Okay, so now we can plug that into our formula, pi r squared. So 270 over 360, that simplifies to 3/4 times 49 pi. 7 squared is 49. 49 times 3 gives us 147 over 4 pi. Okay, feet squared. And we're leaving this in terms of pi. If the directions that say it round to the nearest tenth, then we can use our calculator and multiply this through and get our answer. Okay, so if you can leave it in terms of pi, you can do anything with it. All right, so that's if we're given a whole sector. Segments of the circle. A segment of the circle is the area within a circle bounded by an arc. And the line segment, let's just say line, joining the arc's endpoints. Okay, so you'll notice here that we aren't dealing with a whole sector anymore. We have this segment, just this piece. Okay, so the shaded region of a segment of circle C. To find the area of a segment, you need to find the area of the sector and then subtract the area of the triangle. Picture it is triangle ABC or ACB. Okay, so let's find the area of the segment. So let's look at this. Like I said, we're going to try to find the area of this whole thing that's shaded, this whole thing. We're going to subtract the area of the triangle. So we're finding two areas, subtract them to find what we're actually looking for. Okay, so for the sector, should be pretty straightforward. We have 120 as our arc, measure of our arc over 360. So 120 over 360. We should know at this point that we're dealing with 1/3 of the circle, at least in that whole sector. Okay, our radius is given to us as 24 degrees, or sorry, 24, not degrees. So we have pi r squared, where r is 24. Okay, so as we multiply that, 24 squared gives us 576. So the area of this entire sector would be 192 pi. Okay, that's the entire one. Okay, now we need to subtract the unshaded triangle. Okay, to find the area of the triangle, we need to know a base and a height. Okay, as we break this triangle down, I'm going to do that up here. I'll have a little bit more space, so follow me. Okay, as we break this triangle down, this whole thing is 120 degrees. I am going to, and I know this is 24. I'm going to draw in my height. Okay, the nice thing is I knew that this is an isosceles triangle, so this will split this side. So if I find this side, I'll know this side as well. Okay, and so it was a 120-degree angle. That breaks down to 60. It's a 30, 60, 90 triangle. Hey, it came back to help us. Okay, so 30, 60, 90 triangle. Our hypotenuse is 2x. Our short leg is x. This will be x radical 3. Okay, so now as we're looking here, if 2x is 24, that must mean that x will be 12, half of that. And then that means that this base is 12 radical 3. Okay, and that means this is 12 radical 3. All right, so now as we're trying to find the area of our triangle, the area of the triangle is going to be 1/2 base, which we just found to be 24 radical 3, times height, which we just found to be 12. So multiplying that gives us 144 radical 3. Okay, 1/2 times 24 is 12. 12 times 12 is 144. Okay, so if we're giving an exact answer, we'd say 192 pi minus 144 radical 3. Okay, and it's nice to know the exact answer so that when we have to find our rounded answer, we should be accurate with it. So now we're finding our rounded answer. So we'll type that into our calculator, and that should give us 353.8 or 77. And that is no units, so units squared. Okay, let's look at a couple more here. It says find the area of the shaded region. Leave your answers in terms of pi. Here's how I'm going to think of this. We have a little bit of a different shape here, but I would recommend that what we're going to do is we're going to find the area of this sector and then add to it the area of our triangle. Okay, so the central angle here is 270 degrees, and we should know that because this is 90, right? 360 minus 90 gives us 270. Okay, that simplifies to give us 3/4 of our circle, and our entire area is found by doing pi r squared. And our radius is given to us as 18. So 18 squared is 324. 3/4 of 324. Let's see what that is. 324 times 3 divided by 4 gives us 243. So this whole part is 243 pi. And we're going to add to that the triangle, right? And our triangle has a base of 18, because the base is the radius, and a height of 18, perpendicular, height's radius. And so then we can find the area of this triangle as area equals 1/2 base times height. And so area equals 162 feet, I guess. And so to find the area of this, it says leave it in terms of pi. That means give an exact answer. Okay, so we're going to say 243 pi plus 162 in terms of pi. Problem number 2, let's look at it. In problem number 2, we're finding the shaded region. And so what we need to do here, we notice we have 2 semicircles. So 2 semicircles is basically a whole circle. I know it's arranged a little differently, but it's a whole circle. Okay, so, and this appears to be a square, really has to be a square, because if this is a circle, this diameter is 8, that means this radius is 4, and this radius is 4, meaning it will be 8 here as well. Okay, so we can find the area of this whole square, and then subtract from it the area of the circle, and that should give us the area of our shaded region. Okay, since the circle's unshaded. So area of the square, base times height, 8 times 8, 64 feet squared. Okay, the area of our circle, and it's the entire circle, pi r squared. So pi times 4 squared, 16 pi. So we just have to write this as 64 minus 16 pi. All right, so there we go. Finding area of shaded regions, sectors in our circle. See ya.